So this problem is from Inmo 2018, question number 3. So let's read the problem. Let tau1, tau2 be two circles with respective centers O1 and O2, intersecting in two distinct points A and B, such that A1O O2 angle is an obtuse angle. Let the circumcircle of triangle A1O A2 intersect tau1, tau2 respectively in point C and D. Let the line CB intersect tau2 in E, and let the line DB intersect tau1 in F. Prove that the points C, D, E, and F are concyclic. So let's draw the diagram. So this is tau1 circle, this is tau2 circle. It's intersecting at point A and B. O1 and O2 are the center of tau1 and tau2. Now we are drawing a circumcircle of triangle A01 O2 which intersect tau1 at this point. We call it as C, point C, and this circle as this point D. Now we are joining BC which intersect the tau2 at point E, and again we are joining B and D which is intersecting tau1 at point F. What we need to prove? That C, D, E, F are concyclic. Means these 4 points 1, 2, 3, 4 are concyclic. To prove 4 points concyclic, I just needed to prove this angle is equal to this angle. I spent some time, but I was failed to prove it. Because this chord is nowhere connected to this chord, and this triangle is in no mean is connected to any of these 4 points. I wasn't able to make connection between point O1 and O2 with either of these 4 points. So I got some intuition. Maybe this CE line is passing through O2. So this is your CE line. And maybe this BD line is passing through O1. So this is your BF line. Then I was able to reach to some conclusion. So let's draw the diagram again and see what conclusion I reached to. So now I redraw the diagram, and this time the given line BC is passing through the center of the circle, and the given line BD is passing through the center of the circle. Now I know that points C and D are on this circle, that is the circumcircle of triangle AO1 O2. So the angle subtended by this chord, this angle, is equal to this angle. So let me draw these two chords and this chord. So this angle, say alpha, is equal to this angle alpha. And we also know that angle subtended by any chord on the center of the circle is double of the angle subtended on the circumference of the circle. So that means this angle is alpha by 2. So this angle is alpha by 2. And similarly, this side also, this angle is alpha by 2. Hence we are done, this angle is equal to this angle. So that means these 4 points are cyclic. So what we did here, we assumed that line BC is passing through O and line DB is passing through O. So that means we need to prove that these 4 points are in a one straight line and these 4 points are also in one straight line. So if we are able to prove this, we are done. We can also do reverse engineering, means we can assume that these 4 points are on a straight line and these 4 points are in a straight line, and then prove that the C and D are on the circumcircle of the triangle AO1 O2, and we will be done. So let's assume point C, B, O2 and E are in one straight line, and point D, B, O1 and F are in one straight line. Then we will prove that point D and C are on the same circumcircle of triangle A01, O2. So let's draw these two lines, O1 to A and O2 to A. Now we know that if I draw a line through the center O1 and O2, then this part is exactly similar to this part. So that means that this angle is equal to this angle. So if this angle is theta, then this angle is also theta. Now this is a straight line. So this angle is 180 minus theta. This angle is 180 minus theta. Now we know that these two are radius of this circle. So if they are equal, then this angle equal to this angle. So this angle is also 180 minus theta. Now observe that in this quadrilateral, this angle is theta and this is 180 minus theta. So sum of these two angles is 180. That means they are concyclic. Similarly, we can prove that point D is also concyclic with O1A and O2. Hence, we are done that these 2 points lie on the circumcircle of the triangle A01, O2. I hope you understood the problem and enjoyed my video. Thank you for watching.